right, good morning, everyone. Happy Monday. If you don't have your video on, please take a moment to turn that on for me. We've got like half of you that haven't turned it on yet. Great, thank you. Good to see you all. Here is your do now for today. You have 3 minutes. So in the chat, go ahead and type in what's your favorite restaurant. And then your 2 share out loud questions today are number 2, how do you find the axis of symmetry for an equation that's written in factored or intercept form? And then number 3, what are x-intercepts and how do you find them for an equation in intercept/factored form? So 3 minutes on the clock. Also, just want to give you all a shout out. We got 100% with our video on. Amazing. Period 2 really wins. You guys are awesome. Good job. Dasbo, Henry, you stole mine as well. I had Basbo for Pizza Friday this Friday. So good. Two more minutes. Love Olive Garden. Miss those endless breadsticks. Also, alternative do now question. What's the most amount of endless breadsticks you've had at Olive Garden? Fisher's, I haven't heard of that one. One more minute. I heart mac and cheese. That sounds fun. I do love mac and cheese, but I've never tried this restaurant. I'll have to go check it out, Corbin's. Thirty more seconds. Cheesecake Factory is a good one. All right. How do you find the axis of symmetry from an equation that's written in factored/intercept form? What do you have for me, Henry?
Is it b minus a over 2? Am I completely off?
You're right on the over 2, but instead of b and a, what variables do we have for factored form? Do you remember?
Is it bc?
Not BC. I think you're thinking of standard. Remember, it's P and Q. So it's P
P
plus
and Q.
Q
Oh, yeah.
over 2. And remember that your P and your Q have to be opposite signs. So when you plug it into the formula, make sure you change the signs from the original equation. Good job, Henry. All right, number 3, what are x-intercepts and how do you find them for an equation in intercept or factored form? What do you have for me, Anam?
It's the opposite values for P and Q.
Good job. And then on a graph, where would I find the x-intercepts?
I'm not sure.
They're on the x-axis. So an x-intercept is where your graph crosses the x-axis. So that's why it's always the y value is 0 whenever you write those out as points, because it's where it's crossing the x-axis. Good. All right, let's go ahead and go through our good things today. So today's good things are going to come from Elise, Fresalam, and Gavin. So Elise, what's your good thing? Did we lose Elise? Where are you?
Oh, my good thing is I work today, I guess.
Cool, awesome. Thanks for sharing. Fresalam, what's your good thing?
I got to spend the day with my cousins yesterday.
Awesome, very cool. I love family time. That's awesome. Thanks for sharing. And then Gavin, what's your good thing?
I work today.
Cool, awesome. Thanks for sharing. My good thing was I had a bunch of friends in Indy that moved, and so now they live all over the country. But we decided to get together on Zoom on Saturday night, and then I learned how to play Settlers of Catan, which I'd never played before, and it was so fun. And I'm really excited to play again. So that was my good thing. All right, let's go ahead and get started with our announcements for today. Big announcement is that we're going to have a quiz this Friday over everything in chapter 2. So all about graphing. It's going to be on Big Ideas Math, but I took your feedback and I hope this quiz will be better because I got to choose the problems this time. And it's going to be 30 points, so it's worth 3 homework assignments. We're going to do it during class. But just remember that for the quiz feature on Big Ideas Math, it won't be like homework because you won't be able to check your answers as you go through. So that won't be a feature that is available to you. Any questions about the quiz or what to expect for that?
How many questions?
15. Any other questions? All right, we're going to spend...
How are you going to do the review?
How are we going to do the review? We're going to play a game in class. You guys are going to be my guinea pigs because I haven't done this virtually before, but we're going to play a game and then you'll have an assignment as well for a review.
Okay, thanks.
Yes. Any other questions? Okay, cool. Yeah. So we'll be done with our new material by Wednesday. We'll spend Thursday reviewing and then Friday will be your quiz. Okay, let's go ahead and get started then. Any questions about 2.2 part 3 on Big Ideas Math? That will be due tonight. Okay, everything is updated on Skyward. So up until 2.2 part 2, that should all be updated. I went through all my emails. So if you sent me an email about late work, I should have inputted all your late work as well. So make sure that you go ahead and check your Skyward and make sure that everything's accurate because I have to finalize midterm grades by tomorrow. So if you do need anything changed, make sure you send me an email before then so I can do that for you. All right, let's go and get started today. You'll need 2 things. You'll need your cheat sheet and you'll need the new notes for today. Today we're just gonna kind of review the 3 forms that we've talked about the past week, and we're going to introduce domain, range, and increasing and decreasing intervals. So it's the same type of graphs that we've been talking about last week. We're just adding a couple extra things, little sprinkles on top of something that's already so good, quadratic functions. We love quadratic functions. All right, let's go and get started. Example 1, I've got 1/2 x squared minus 2x minus 1. First question, what format is this equation written in? Is it standard form? Is it vertex form? Or is it factored form? So if you look at the top of your cheat sheet, it has all the formulas for you. So I need you to tell me which format this is in. What do you think, Christian?
What was the question again?
What format is this equation written in? Is it standard, vertex, or factored form?
Standard.
I agree with you. Yep. So now that makes it easy because we are just going to focus on that leftmost column when we answer these questions. So I really only care about this guy over here. All right, you'll notice that I'm asked to find things that are slightly different than what we've found before. So you want to find maximum, minimum, domain, range, and increasing/decreasing intervals, and we want to graph. But there's a sneaky thing that we actually need to find before we can do any of that, and that's the vertex. The vertex is the most important point on your graph, and even though the assignments today will not ask you to find the vertex specifically, you do need to know where the vertex is in order to find the rest of the information. So that's a little sneaky part of today's lesson. All right, we've talked about how to find vertex. How do I find vertex in standard form? What do you think, Noah?
You plug in the axis of symmetry into the equation to get the y value.
Good, and then Noah, how would I get the axis of symmetry?
Negative b over 2a.
Good. So we have to figure out what our A, B, and C is before we can use our formula. What's my A, what's my B, what's my C? What do you think, Jonathan?
A equals 1/2, B equals -2, and C equals -1.
Perfect. And then like Noah said, we have to use negative B over 2A to find our axis of symmetry. So B is already negative, so I need to change it to a positive 2 over 2 times 1/2. 2 times 1/2 is 1. So 2 over 1 equals 2. And now that we have that, we have to plug it back in for x. So everywhere you see an x, you're going to plug in 2. So it's 1/2 times 2 squared minus 2 times 2 minus 1. So we've got parentheses. Anytime you have a fraction, you want to put it in parentheses. 1 divided by 2, parentheses 2 squared minus 2, parentheses 2 minus 1, and that gives us -3. So your vertex is the axis of symmetry, which was 2, comma, whatever you got when you plug that in. So 2, -3. All right. Next question. Let's go ahead and figure out what our max, if we have a maximum or a minimum, and what that value is going to be. So do I have a maximum or do I have a minimum in this problem? What do you think, JJ?
So we're looking at, since C is -1, wouldn't it be max?
So you want to look at the A value, JJ. So what's the A value?
Okay. We're looking at 1/2.
Mhm.
So it's minimum.
Yep, because it's positive, good. And then what would that value be, JJ?
It would be -3.
Because it's the Y value of the vertex. Good job. All right, we're going to pause right here and we're going to go ahead and graph this before I talk about the domain, range, and increasing/decreasing. So remember, in order to graph, you're going to just create a table of values. Your vertex is going to go at the top. And then you just have to choose one other point. I choose one point to the right, or in other words, a point that's greater than your vertex x value. So I'm going to go with 3. So we're going to plug in 3 everywhere that you see a x value in your original equation. So it's going to be 1 divided by 2, parentheses 3 squared, minus 2, parentheses 3, minus 1, and that's going to give you -2.5. So let's go ahead and graph this. The vertex is at 2, -3. You have your axis of symmetry that goes through the vertex at x equals 2. And then you've got this point 3, -2.5. And remember, you only need this point because now you can reflect it over the axis of symmetry to get your third point. And then you can connect those together to make your parabola. I'm not super concerned that you can graph. You should know what the graph looks like, but on Big Ideas Math, you just have to, it's a multiple choice, so you just have to recognize what the graph looks like. So as long as you can kind of visualize that, then that's all I really care about. Questions on the graph? All right, let's talk about domain and range. So we kind of glanced over it last week, but today we're gonna get kind of more in depth on it. Domain always has to do with your x value. So it's asking you what possible x values can this function have. So if I look at my x values, let's look to the left of my graph. This arrow means that I'm going forever and ever and ever in the left direction. So I could have an x value of 0. I can have an x value of -1. I can have an x value of -2. I can have an x value of -10. I can have an x value of -1,000 if I wanted to. So there's no restriction on that. And then if we look to the right side, I can have an x value of 1, 5, 10, 1,000. It's going forever and ever and ever in the right direction as well. So basically, there's no restriction on my domain. I can have any x value I dream of. So the way that we say that is that the domain is all real numbers. And that's actually a freebie. For quadratic functions, your domain will always be all real numbers. So if you look at the cheat sheet, you'll notice that that column for, or not column, that row for domain, no matter what format you have, is always going to be all real numbers. So that's a freebie for you. For quadratic functions, domain will always be all real numbers. The range is a little bit tricky because the range deals with the y value, so how high and how low your graph can go. If we look at this particular graph, how high it can go as far up as it wants to. That's what those arrows mean. It's extending forever and ever. So I can have a y value of 1, 2, 6, 8, 10, 12, whatever I want, all the way till infinity. But there is a lowest point. So that lowest point is right here where y equals -3. You'll notice that there's nothing else below that. There's nothing else below that. So the range in this case, the way we say it is y is greater than or equal to -3. So it's all the y values that are greater than or bigger than -3. And if you look at your cheat sheet, you'll notice that the way that you say the range is dependent on whether you have a minimum or a maximum. So JJ said that we had a minimum, so we should look at this part right here. If we have a minimum, it's y is greater than or equal to the minimum value. So in this case, the minimum value is -3. Questions on range? All right, the increasing and decreasing intervals, there's quite a lot I want you to write. So we're going to write a phrase and I'm going to leave some blanks in that we're going to fill out. So I want you to write the function is decreasing to the blank of x equals blank and increasing to the blank of x equals blank. Anyone need more time to write that down? All right, the big point that you want to focus on is the x value, and the x value is going to be the x value of the vertex, in other words, the axis of symmetry. So we want to focus on x equals 2. So you always fill in the blank for the x's with the x value of the vertex. So basically, on my graph, I'm focusing on this point right here. That's my most important point. You always read a graph from left to right. So this is your maximum, minimum, that's your stopping point. If you're looking at it from the left all the way to the vertex, you'll notice my graph is going down. So we say that that's decreasing. So read it from left to right. From the left all the way to the vertex, it's going down. So that's decreasing. And then you'll notice it starts turning at the vertex. That's the critical point. That's where things start changing. Instead of going down, now it's going up. So to the right side of my graph, it's increasing. So the function is decreasing to the left of x equals 2, where the vertex is, and it's increasing to the right of x equals 2. Any questions about how we filled out the blanks for increasing and decreasing intervals? On Big Ideas Math, it's going to be drag and drop, so you just have to fill in those blanks with those terms when you're doing your assignment tonight. All right, let's go ahead and, are there any questions before we move on to example 2? Does anyone need more time? All right, example 2, f of x equals 4x squared plus 16x minus 3. What format is this written in? Is it standard, vertex, or factored? What do you think, Clervins?
Standard.
Standard, correct, Clervins. And then could you take it a step further? Can you tell me what my A, B, and C is?
A is 4, B is 16, and C is -3.
Beautiful, thank you. How can I find, remember, the sneaky thing that you have to do before you can find the maximum and minimum and all the other good stuff is you need to know what the vertex is. How can I find the vertex for standard form? What do you think, Ida?
You'd have to solve for the axis of symmetry, so you do -16 over 2 times 4.
I'm going to do it down here so I have a little bit more room. Good job. So it's -16 over 2 times 4, which is 8, which gives you -2. Ida, what do I do now that I have that -2?
You'd plug it in for the x's.
So it's going to be 4 times -2 squared plus 16 times -2 minus 3. Take out your calculator, you've got 4, -2 squared plus 16 times -2 minus 3. Oh, but I put a 9 in there instead of parentheses. I was like, that's too big. Let's try it again. Perfect, -19. All right, so your vertex is at -2, -19. If you look at your graph, you'll notice the graph is not big enough for that. So what I would suggest doing is just change the numbers, like change -2 so that it's -12, -14, -16, -18. That will help you graph it. Like I said, I'm not too concerned about the graph. It's just kind of to help us visualize the domain range and increasing and decreasing. So let's do -2, -19. So that would be somewhere over here. And we're going to draw our axis of symmetry that goes through it. But you need 2 other points. So we will need a table of values. Remember, your vertex goes at the top. So -2, -19 goes to the top of your table of values. What other x value can I choose for my table of values? What do you think, Nick?
-3.
You can do -3, yeah. I usually use one that's greater than, but -3 will also work. That's fine. You just want to choose something on either side of the vertex. So if I plug in -3 into my function, it's going to be 4 parentheses -3 squared plus 16 times -3 minus 3, and that's -15. So go to -3, -15. Now we can reflect that over the axis of symmetry, and we have 3 points now. So go ahead and connect those together. There's your long, skinny parabola. Any questions about the graph? All right, am I gonna have a maximum or minimum, and what is that value going to be? Maximum or minimum, and what's the value? What do you think, Jaden? What does our cheat sheet say to find maximum and minimum value?
Maximum.
Well, what does the cheat sheet say? What is it dependent on? It's dependent on
Y value.
the A value, right?
Yeah. Oh,
So what's your A value?
4.
Is that positive or negative?
It's a minimum.
And then what's that value going to be, Jaden?
-19.
Because it's the Y value for those. Good. Good job. All right, what's the domain going to be? What's the domain going to be? What do you think, Natalie?
Wouldn't it be all real numbers?
That's always a freebie because domain will always be all real numbers for quadratics. Good. What is my range going to be? What's my range going to be? What do you think, Fressalum?
The range is going to be y is greater than or equal to -19.
Perfect. Yep, because it's a minimum, so you have to have y is greater than or equal to whatever that minimum value is. And then let's do the increasing and decreasing part. So I'm going to copy down the phrase and with the blank. So go ahead and copy it down with me. The function is decreasing to the blank of x equals blank and increasing to the blank of x equals blank. Ooh, that last line was not good. That's okay. All right, what am I gonna fill in the x equals blank? What am I gonna fill in the x equals blank? What do you think, Imani?
Ain't it -2?
Yep, it's always the x value of your vertex, so it's -2. So if you look at your graph, read it from left to right. So from the left all the way to -2, you see that it's going down, so it's decreasing. And then from the vertex all the way to the right, it's going up, so it's increasing. So to fill it in, the function is decreasing on the left side, so to the left of x equals -2, and it's increasing on the right side. Increasing to the right of x equals -2. Questions on number 2? All right, when you're finished, flip the page and we'll do the last example. Does anyone need more time for example 2 before I flip it? All right. Last one, negative x squared plus 5x plus 9. That is also in standard form. And we have to find the vertex. So like you also all said before, to find the vertex in standard form, you are going to need to find the axis of symmetry, so negative b over 2a. So your a is negative 1, your b is 5, and your c is 9. We go over here so I have a little bit more room. So x equals negative b, so negative 5 over 2 times a, which is negative 1. 2 over negative 1 is negative 2. Negative 5 divided by negative 2 is 2.5. You can leave it as a decimal. And then we're going to plug that into our original equation. So it's going to be negative 2.5 squared plus 5 times 2.5 plus 9. Take out your calculator. So you've got negative 2.5 squared plus 5 times 2.5 plus 9. And it's equal to 15.25. So your vertex is at 2.5, 15.5. All right, first question. Do I have a minimum or do I have a maximum, and what's the value? What do you think, Elise?
A minimum.
Well, it's always dependent on the a value, right? Elise, is your a value positive or negative in this problem?
Negative.
And what do we know? If a value is negative, what do we have?
Positive or maximum.
A maximum. And what's that maximum value going to be, Elise?
What?
What's the maximum value going to be?
Negative 1.
Remember, it's always
What?
the y value of the vertex. What's the y value of your vertex?
I don't know.
What do we just find the y value of our vertex to be?
2.5.
3.5?
2.5.
That's the x value. What's the y value?
I don't know.
What's the for an ordered pair, it's x comma y. So what's the y value?
15.25.
What's the domain? Actually, before we do that, let's go ahead and graph it. So same thing over here. Your graph won't be big enough as is. So we're going to change the y values to 12, 14, 16, 18, and then you should be good to go. So the vertex is at 2.5 and 15.25. So somewhere about here is fine. Draw your axis of symmetry that goes through that. And then your table of values. Put the vertex at the top, so 2.5, 15.25. You want to choose a number that's bigger than 2.5, so you could go with 3, but I think it's better if you choose 4 because 2.5 and 3 are really close together, so it's going to be kind of hard to graph both of those next to each other. So I'm going to plug in 4 in my calculator everywhere I see an x in the original equation. So it's going to be negative 4 squared plus 5 times 4 plus 9, which is 13. So 413. And then you just reflect that over the x-axis, or not the x-axis, the axis of symmetry. And then you can connect those points together to make your parabola. Any questions so far? All right, what's the domain gonna be? What's the domain gonna be? What do you think, Gavin? Do we lose Gavin? Gavin, where are you?
Isn't it just all real numbers?
Yes, it's all real numbers. So that's always a freebie. Domain is always all real numbers. Good job. What's the range gonna be? What's the range gonna be? What do you think, Tyler?
I'm not sure.
Tyler, let's look at the range over here. Do I have a minimum or do I have a maximum for this problem? What do you think? What'd you say, Tyler? Sorry.
I don't know.
Well, what did we say earlier for part A? Did we say maximum or a minimum?
Oh, maximum?
So then we have to follow this. So y is less than or equal. What did we say the maximum value was, Tyler?
Is that the 15.25 one?
So y is less than or equal to 15.25. Remember, since it's a maximum, it has to be less than or equal to, And the last part, we're going to do the increasing and decreasing values with the blanks. So the function is decreasing to the blank of x equals blank and increasing to the blank of x equals blank. All right. What goes in the x equals? What goes in the x equals blank? What do you think, Naya?
I don't know.
It's always the x value of your vertex. What's the x value of our vertex?
2.5.
So let's look at that on the graph. So here's our vertex. On the left side, so on this portion right here, is it increasing or decreasing? What do you think, Noah?
Decreasing?
Oh,
No, increasing.
it's increasing. So when you read it from left to right, up and from the left side to the vertex, it's increasing, which means that from the vertex to the right side, it's decreasing. So it's decreasing to the right now of x equals 2.5, and it's increasing to the left. So switch from the last examples. Questions on example 3? Questions on example 3? All right, does anyone still need this before I switch the screen? Okie dokie. All right. Here is your homework for tonight. You have 2 assignments that are floating right now. You've got 2.2 part 3. That'll be due tonight at 11:59. And then you've also got 2.2 part 4. That'll be due Tuesday at 11:59. So that's all I got for you. If you have any questions, I'll stick around till the end of the period. If not, I will see you tomorrow.